So in order for a piecewise function to be differentiable at a point of, I call it a point of transition, that's kind of my loose word, like C. See, this piecewise function is jumping at C. The slope as x approaches C from the right has to equal the slope as x approaches C from the left. So in other words, if the function is defined with these two mini functions within it, then the limit as you approach C from the left, which would be following the g of x, is going to have to equal the limit as you approach C from the right. So again, per usual, the generic definition makes it seem more confusing than it is. So we'll just jump right into a concrete example. So determining any points at which the function may not be differentiable. Obviously, you should still take a look within each interval. So anytime this is less than 2, we're dealing with a quadratic, so we'll always be differentiable just by the nature of that graph. And this one's linear. So once we're greater than 2, we'll always be differentiable. The question is what happens right at 2. So we want to know what the derivative is at 2, specifically when you're coming at 2 from the right, and then the derivative at 2 specifically when you're coming from the left. So each of these has its own derivative formula. If you're coming from the left of 2, your derivative is just 2x. When you're coming from the right of 2, your derivative is just negative 2. So this is the right, and this is coming at x from the left. So the derivative at 2, if you're coming from the right, is just negative 2. Your derivative at 2, if you're coming from the left, you would actually have to plug into this equation, which would be 2 times 2, which would be 4. So they do not match, and therefore this is not differentiable at x equals 2. If I sketch a graph for this, this is a parent graph of x squared that ends at 2, 4 with a solid circle. Prior to that, it's just going to look like this. And then 8 minus 2x, 1, 2, 3, 4, 5, 6, 7, 8, is going to start at the point 8 minus 2 times 2, which is 8 minus 4. So it's going to start at 1, 2, 1, 2, 3, 4. So it's going to start there, but it's going to have a slope of negative 2, down 2 over 1, and it's going to look like this. So the fact that one ends where the other begins tells us that we're continuous, and that's great. But the derivative, or the slope coming into it from the left, is what we calculated here. That slope was 4. And the slope coming out of it, obviously being that it's linear, was negative 2. So that creates this sharp corner point, which we know it's not differentiable at that location. Okay, so one of the main things to keep in mind is, in your own head, keeping it all straight, continuity, which is f of 2 coming from the left and f of 2 coming from the right, that's one thing. F prime of 2 coming from the left and f prime of 2 coming from the right, that's differentiability. Do we follow that? Any questions? Okay. Correct. Absolutely. So if you're differentiable, you're inherently continuous. So the contrapositive of that is that, the double negative, so to speak, is that if you're not continuous, there's no way you can be differentiable. Yes? Good. I think I tried to come up with examples of a couple different types. So on this next one, if I look at f prime of 3 coming from the left and f prime of 3 from the right. First, I'm going to find each derivative. So that one's got f prime coming from the left. We follow 2x. F prime of x, 1 second, Josh, coming from the right is also 2x. So with this one, you're going to get that the slope coming from the left, when you plug in 3, is 6. And if you look at the slope coming from the right at 3, it's also going to be 6. So you have to be careful here, though, because this one, I believe, when we sketch it, you're going to see that it's not differentiable at 3, even though they match. Because exactly what Jalen just said. So x squared plus 5, that's a quadratic shifted up 5. 1, 2, 3, 4, 5. So it does something like this. And we have a closed circle that's at 3, comma, 9 plus 5 is 14. The other graph is going to be an x squared shifted down 7. And it starts at, when you plug in 3, 3 squared is 9, 9 minus 7 is 2. This one's graph starts at 3, comma 2. With an open circle. And does this. So what you find is that even though the slope coming in from the left is 6, and the slope coming out from the right is also 6, because it's not continuous, you can't be differentiable right at 6. So really that test should come first, is the moral of this story. The first thing you should test to see if something is differentiable is, number 1, step 1, be sure it's continuous at that C value, whatever that C value might be. In this case, it's 3. If it's not continuous, stop, because it's not differentiable. You might want to write that. If not continuous, not differentiable. If it is continuous, step 2 is going to be check f prime of C coming from the left versus f prime of C coming from the right. Josh. Correct. Yeah. But I wanted to do that, and like I know there's a slew of people that would be at 6. We're good to go. They both equal each other, but you're not. And then show you the graph and obviously visualize why you're not. Okay. Why the derivatives could both be 6, yet it's still not differentiable there. Okie doke. Any questions? Okay. Are we too hot? Is it too hot in here? Why don't you try this one on your own while I do temperature control? On the denominator? I think it's a minus. Oh, yeah, that's just, oh. It's a minus. I don't know if I accidentally wrote a plus in. Zach, what'd you find over there so far? Did you do step 1? Okay, so what did you find there? Okay, and so if it's not continuous, then there you go. Not differentiable at 0. Okay, if you check the continuity, you're going to get that this particular graph starts at 0, 3. Open circle, and it's an exponential parent graph, so it looks something like that to the left of 0. And then to the right of 0, it starts at negative 2.5 with a closed circle, and then obviously it's just that jump there. We know it's not continuous. So it's not differentiable at 0. Reminding you that we're trying to find any points that this function in its entirety is not differentiable. Liam, what do you have to add to that? At 2. So with this one, I threw a rational function within it so that we had an asymptote within this interval. So we're also not going to be differentiable at 2. Because, now, not because of the same tests we've just been working on, but because of the nature of that graph. We have an asymptote at 2. So prior to 2, we're doing something like this. So again, always being, well balanced with your thought regarding kind of definitions, but also what the look of the graph and the features of the graphs are that lead to discontinuities. Any questions there? Okay, and on the last one, we're asked to find the b, such that f of x will be differentiable for all real numbers. So, again, starting with conditional number 1, if we want it to be differentiable for everything, we need this to be continuous. So we need to make sure we're finding the appropriate b value that's going to make this continuous, which this has to end at 3 squared plus 5, which is 9. So we want this one, when x is 3, to start at 9. So 6 times 3 plus b, we want that to equal 9 as well. So, thank you. We want that to equal 14 as well. So then we have 18 plus b equals 14, subtract 18 from both sides, and b equals negative 4. So once we think we know that b is negative 4, we should double check that we are differentiable at 3. So the slope at 3 coming from the left, again, that derivative formula is just 2x, so that'll be 2 times 3, which is 6. And the derivative at 3 coming from the right, the derivative of that is always 6. So we confirm that they have the same slope. And the reason we would check that is because, so we found the b that makes them continuous. It's possible that there is no such b value that would make them continuous and differentiable. So even though we found the b that made them continuous, we still wanted to check the differentiability in case the answer was there is no b, the b does not exist. But obviously we just confirmed that it did. Okay? Any questions on that? All right. I want to